we're discussing with electrovalent bonds, and it's the continuation of chapter 4. So electrovalent bonds, you have to remember this, are formed between metals and non-metals, and metals are those elements which contains 1, 2 or 3 electrons in the valence shell, and non-metals are usually those elements which contain 6, 7 electrons in their valence shell. So this electrovalent bond is also known as what? Ionic bond. So let me first give you an example. After that, I'll tell you from that particular example, you'll come to know what are electrovalent bonds. So you have heard about NaCl, common salt, the table salt that you take every day. So how come you not know about this NaCl? So you have to also know how the bond is formed between sodium and chlorine. So for that you need to know about its electronic configuration. Sodium's atomic number is 11, so 2, 8 and 1. The electrons are arranged as 2, 8, 1 in the cells. Similarly, for chlorine, the atomic number is 17. The electrons are arranged as 2, 8 and 7 in the respective cells. Now, let's draw its structure. As I have asked you to draw all the structures. Now here, that will be very helpful. So sodium is present here in the nucleus. Sodium is present. Now here, we have first cell, second cell, and the third cell. Okay, so in the first cell, we have 2 electrons. Second cell, 1, 2, 3, 4, 5, 6, 7, 8. These electrons, and in the last outermost valence cell it has 1 electron. Similarly, in case of chlorine, we have again chlorine at the center, the nucleus, first cell, second cell, third cell. So in the innermost cell it has 2 electrons, these 2 electrons, after that comes 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, these 8 electrons. And in the valence cell, that is the outermost cell, it has 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Now, from our previous discussion, we have discussed about octet rule. So I have told you, if any element, atom of any element has 8 electrons in the valence cell, then that will be very, very stable. Therefore, in the process of combining, why do these elements react? They react so that they can be stable. Now here what will happen is, sodium, if this 1 electron is lost from sodium, that means it has given to, say, chlorine. Then what will happen? It will have 8 electrons in the valence cell. Yes or no? Similarly, now if this chlorine gains 1 electron, that means 7 plus 1 would be also 8. Then this also would be stable, and this would also be stable. So this is the reason why these elements they react. Okay, so what will happen? This 1 electron from sodium gets transferred to chlorine, to the outermost cell of the chlorine. Now as this happens, what will happen? As this takes place, what will happen? Now this outermost cell will be removed from sodium. That means it is left with only 2 cells where it has 1, 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons. That means this outermost cell contains 1 electron. Now it has been donated to chlorine. Now this cell is not present. That means it's left with only 2 cells. And in the outermost cell, now the second cell becomes outermost cell, and which contains 8 electrons. And this is now very stable. Okay, now once it loses 1 electron, since previously it was neutral, now it will convert into what? It will convert into positive charge. It will have positive charge. Similarly, now this chlorine, 1 cell, 2 cell, and the third cell. So first cell, it has innermost cell, it contains 2 electrons, and then 8, 3, 4, 5, 6, 7, 8. And now here, previously contained 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Now since 1 electron has come from sodium to chlorine, now this also contains 8 electrons. And now the electronic configuration of this is what? Sodium is 2, 8, and the electronic configuration of chlorine is 2, 8, and 8. Now this will, since it has been 1 electron, it has overall 1 excess negative charge, therefore it has negative charge now, it is anion. This has turned into cation and this has turned into anion. Now, so let me draw this part. So sodium now here will be acting as what? It will be having a positive charge, and this chlorine will be having a negative charge. Now there is a force of attraction between this positive charge and this negative charge, and this force of attraction is what? Electrostatic force of attraction. Electrostatic force of attraction. And this electrostatic force of attraction is what happens? What does it do? It brings both cation and anion together, and they are bound very tightly. And this gives rise to what? This gives rise to electrovalent bond or ionic bond. Why? Because in the process of doing so, transfer of electron, one of the atom of the element has turned into positive ion, that is cation, and the other one has turned into anion, that is negative ion. And a force of attraction exists between this cation and anion, and this force is known as what? Electrostatic force of attraction. And the bond formation here is known as what? Electrovalent bond or ionic bond. Okay, so remember this. Now, similarly, and these structures are very important for you. You have to learn them. And similarly, you can draw such structures, orbital structures for magnesium chloride, and one more, that is calcium oxide. So I request you all to try these orbital structures for magnesium chloride and calcium oxide. Okay, that will be your assignment. Now, so from this example, we come to know what? Electrovalent bonds are those bonds, okay, which are formed by transfer of electron, as it happened in case of what? Sodium. 1 electron was transferred from sodium to chlorine. Okay. Now, therefore, electrovalent bonds are those bonds which are formed by transfer of electron from one particular element, one particular atom of the element, that is metal, from metal to non-metal. And this will give rise to electrovalent bond or ionic bond. So, this was for today. We will be discussing about covalent bond in our next video. Till then, stay safe, take care, thank you.